So hello everyone, welcome back to our channel Known for Knowledge. So today we are going to learn about the third part of the chapter, that is the refraction part. So in the previous class we have learned about what is actually refraction, what is refractive index, what are the laws of refraction, and we have finally seen what is actually the absolute refractive index. So we have covered all these important points in the previous class, and there was actually some technical glitches and errors, because of which I have to end the uh, 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 I have to end the video abruptly in middle after I completed this. So this video we are mainly going to see the refraction by the spherical lenses. So how we can actually draw the rules for the ray diagrams that we have to follow. Then what are the image formations that we are going to see. Then for both concave and convex, those both we are going to cover. And after that we are also going to see about magnification. Then finally we are going to solve some numericals, and after that we are going to end with the power of lens, that is power of lens, what is actually power of lens, and what is its SI units and everything. Yes, it's perfect. It's going perfectly live. Now let us continue. So as I already told you, we are going to learn about the spherical lenses first. First, let us try to understand what is actually a spherical lens. A spherical lens is nothing but it is curved. Okay, a lens is nothing but it is just a transparent medium. It is a transparent material. So what is actually happening through the lens, or any other substance also, any other transparent medium also, you have to remember that always in a transparent medium, the refraction will actually take place. Whereas if you see any plane surface, then the reflection is actually happening. There is a difference between refraction and reflection that you have to remember, because refraction is happening in the transparent mediums. That means with the help of a thick glass slab, or in the case of the lenses, and all these cases we are actually seeing that the refraction is actually happening because there is a change in the medium, right? There is a change in the medium from air medium, there is a change in medium from air medium to again the glass medium to the air medium, right? So therefore that means when there is a change in the medium, you have to remember that it is a refraction. Okay, but if you see the reflection, there is no change in the medium, just it is striking in the surface and it is just bouncing back. Therefore in that case it is reflection. So in this case you have to remember what is actually refraction, what is actually reflection also. So that is a lens. The lens is nothing but it is just a transparent medium which is bound by two surfaces. So two surfaces is nothing but one surface will be like this, or other surface may be like this. It depends on the medium. Okay. So so in these lenses also there are actually different type of lenses also. For example, we have bifocal lens, biconcave lens, biconvex lens. We have a planar convex lens. Then we have planar concave lens. So in this case we are actually having different kind of lenses. So biconcave biconcave lens is a kind of lens wherein both the surfaces are actually curved. For example, you think this is a so this is the biconcave lens. So if you see this concave lens, it is thinner in the middle and it is thicker in the edges. So that you have to remember. So this is a biconcave. So this biconcave lens only we are going to see more in detail with respect to concave. With respect to concave, this kind of lens is used more in our syllabus. In our subject, we are going to use this kind of lens in more. Okay. And one more important thing is this biconvex lens. If you see biconvex lens, it is thicker in the middle and thinner at the edges, which is opposite to that of the concave. So this is biconvex lens. Okay, so which is thicker in the middle and thinner at the edges, whereas concave is thinner in the middle and thicker at the edges. That you have to remember. So if you see here, so this means that a lens is bound by at least one spherical surface. One spherical surface, at least one side should be a spherical surface. But I can just try. Okay, that you have to remember with these lenses, right? Now let us try to understand what is actually okay. So if you see here, as I already told you, if you extend this complete side of the convex lens. So if you see, it will actually form a part of it is actually form of a circle, and these are also, if you extend, it's a circle, right? So if you see, this is a circle, right? So here also one center will be there for the circle, that is called as a center of curvature 1. So that means here what is actually happening, we are actually seeing that two circles are actually forming here. So one is this circle and one is this circle. That means we have two center of curvatures, we have two focal length. Focal length is going to be same for both the circles, because with respect to that only, one is not going to be big and one is not going to be small. Both are going to be same equal, or one we are actually going to see. Okay, that you have to remember. So that means two center of curvatures will be there and two focal lengths will also be there. So it is a similar case for the concave lenses also. So if you extend this side, then we also see that two center. So this is one circle and this is also one more circle. That means two center of curvatures are there and two focal lengths are also there. So that means F1, and we represent it with C1, C2 or F1, F2. Otherwise you can, instead of F1, so C1 is nothing but it is a center of curvature. That means, so if you see, so this is just the radius of curvature, right? So this is just the radius, right? So you can just take it as 2f1. That means 2 times of f1 you can take. Otherwise you can take it as c1, whichever way it is convenient for you. You can take that way. Okay. So it is mostly your preferable way. Which one is more easy for you to remember? That way you can actually take it. So if you see here. So if you see, I'm actually trying to extend. It is actually this big circle. That means what is actually happening? Okay. So this big circle, right? Now what is actually happening here? In this case, if you see, I don't know why it is just connecting all the time. So these days I'm actually facing a lot of network problems, because of which okay, I think I have just the connectivity issues this time. Okay, so if you say, as I already told you, this is, if you extend this side, this is a two center of curvatures that you have to remember. Okay, so now what is actually happening? Now let me actually define you each and everything. So this point O is considered to be the optic center. Okay. And the centers of these pairs are called as the center of curvatures that you have to remember, which is represented by C1, C2, depending on your easy understanding. Okay. So then, so the effective diameter of the circular outline of the spherical lens, effective diameter of the circular outline of the spherical lenses, that means whether it is this one or whether it is this one, that is called as the aperture. So if you see in the concave lenses also, the part of the reflecting surface which you are actually going to take is considered to be the aperture. So based on that, you have to see which one is actually your aperture or not. Okay. So here they are actually trying to give you examples here. So if you see convex mirror, see what you have to remember with respect to concave and convex is that in reflection we saw that 6 cases are actually there for the image formations for the concave mirrors, and 2 cases are actually given for the convex mirrors. But it is kind of opposite now. 6 cases are actually there for the convex lenses and 2 cases are only there for the concave lenses. So that you have to remember. Then what you actually get to a point, that means convex lenses are actually helping in focusing of the light. Therefore, if you see the magnifying glasses also, we use a convex lens. Why the convex lens? This is because it helps in the focusing of the light ray. So if you keep at certain distance, if you keep from, when the light is actually coming from the infinity, so that means the sunlight, if you try to focus it on a paper, then if you see the all light rays are actually merging at a particular point. Then that point, if you see, if you go on keeping the magnifying glass for that point only, then you can actually get a heat, that you can actually, the paper starts to burn because all the light rays are actually focused at a single point. So that you have to remember in this case. So that is an example of the convex lenses. And with respect to that also, there are many cases we use convex and concave lenses. For example, we use the concave and convex lenses depending on the sight of a person, right? We cannot use concave and convex mirrors. Why we cannot use? Because they help in reflecting of the light ray. They'll not help in allowing the light ray into our eye. If you use concave or concave or convex mirrors, can we actually see? We cannot actually see, because if they'll just strike the light ray and they'll reflect backwards. Therefore, we are only going to use the lenses, that is a concave or a convex lenses, depending upon the sight of the person, whether they are able to see only far objects, whether they are able to see only near objects. So depending on that, we are mainly going to see whether they have to use concave or convex lenses. If you want, concave lenses are mainly used by the people with a myopia defect. Myopia is a kind of defect wherein they are able to see only nearby objects. Far objects are not able to see, are not seen by them. And hypermetropia is a kind of condition wherein they are only able to see the far objects and nearby objects are cannot be seen. They are not able to see. So in that kind of situation, they are going to use the convex lens, where they are able to converge the light, and the light is actually falling on the retina. Okay, so that you have to remember. Okay, now let us try to understand this image formations. Before that, let us go to what are the rules that we have to actually follow. Everything is similar to if you just remember for the reflection, you can write it immediately, easily you can write it for the refraction. Just everything is going to be most the same. Okay, so but the thing is that it will actually, the light is not bouncing back, it is not going into the same medium, but it is actually traveling straightly. But if you see it is reflection, the light is actually coming back, right? But here light will not come back, it will just move back, it will move straight. Okay, so if you see the lenses, that means the rules for drawing the ray diagrams for the lenses. First rule is that when the light is actually traveling parallel to the principal axis, when it is traveling parallel to the principal axis, after striking this lens, after striking a convex lens, let's talk about convex, it is actually meeting at a point. That point is considered to be the focal. Where it is actually meeting at a point, that it is actually passing through the focus. That is the point. Okay, so if you see, so therefore we are mainly in exams also, if you want to see, this focus is only mainly considered for the exam. You are not going to consider this focus because the light is actually striking here. Therefore, this focus is used for the exam. That means, in what sense? That means in order to calculate the value, that means sometimes f will be positive or negative, right? So in that case, f is always taken as positive in this case, because the light rays are always moving towards the direction, therefore f is taken positive. But if it is away the direction, but if you see in this case, the light rays are actually moving towards the lens, but when actually we are measuring, we are taking from f we are taking from O to F. That means we are going opposite at the direction of the light rays which are falling. Therefore, in that case, we are going to take the focal length as negative. So in this case, if you just remember, you can understand it easily. Otherwise, if you are not able to remember, I'll tell you a trick we have to remember, how we can easily remember that also. Okay. So if it is traveling, if a light is traveling parallel to the principal axis, all the important definitions will be seen. This is optic center, and this is the focus, F focus 1, and this is focus 2. So the light ray, when it is traveling parallel to the principal axis, after striking the lens, it will move through the focus. The next important point is that when the light is actually traveling parallel to the principal axis in a concave lens, after striking the mirror, it will diverge. So here it is converging and here it is diverging. So what is actually happening? This light rays are actually meeting, they are actually appearing to meet at a point. So therefore, this will always form a virtual images. Okay. So this is actually appearing to meet at a point, that is F1. So like that you have to remember. The second case is that when the light is actually traveling through the focus, when it is traveling through this focus, otherwise you can draw whichever way is comfortable. You can draw from here or here anyway. Okay, when it is traveling through the focus, okay, then after striking the mirror, it will travel parallel through the principal axis. Okay, so if you see this one also, if it is actually traveling through it is actually appearing to travel through the focus. After striking the lens, it will travel parallel to the principal axis. Okay, then the third case is wherein it is actually traveling through the optic center. If you, as you have seen in the reflection case, the concave or the convex lens, when it is actually striking the mirror, it is actually bouncing back again to the same path. But in this case, as this is a lens, the light is actually traveling through the same direction. It is not bouncing back because it is not a L mirror to bounce back. So it is a lens. Therefore, it will travel through the same path when it is only moving through the center of optic center O. It is not when it is not passing. So you have to, here you should not take about the center of curvature. Here you should mainly focus about the optic center only. That you have to keep in mind. Okay. So then the ray diagrams, how can these are very important ray diagrams. So the first case is wherein, I don't know why this kind of a situation is arising. It is just disconnecting in between. At least for these diagrams. Okay. But now it's fine, I guess. So the first case we are actually going to see is about, so let me actually open a whiteboard for you. So before, so that you can easily get. So now I can I'll try to show it to you. Okay. So the first case we are mainly going to see is about the when the object is at the infinity. Same, everything is going to be just the same. Just you have to remember where it is just located. So when the object, so I'll just represent the object with U. Okay. So when the object is at the infinity. Okay, when it is at the infinity. So if you see here, so this is C, this is F, and this is again F, and this is C. You have to draw every time. We don't know where the object is there. That's why we are going to take it as infinity. Therefore, when it is striking the mirror, it is actually traveling through the focus. Sorry. Like this, it is traveling through the focus. Okay, so then after that, so in this case you have to take 2 light rays. So at least for any image formation you have to take at least 2 light rays, or more than that also you can take. But in exam also, if you want to represent, you can just take 2 light rays. So it is meeting at focus. So the same points what you have to remember. So what the object is there. So when object is actually formed towards this side, so it is, I have to always consider it is real, it is inverted. Inverted, why do we say inverted, is because it is slightly little bit below the principal axis. Therefore, it is inverted. But most of we take it as points. Otherwise, just you can mention it as point sized. Point sized or diminished, you can say. Okay, real and point sized, you can say. But where the image is formed at the focus. So where the image is formed at the focus. Right? Now you got an understanding where the object is at infinity, image is formed at the focus. Same points which are actually there for the concave mirror also. Okay, so then the next case, wherein the object is actually where the object is actually there beyond C1. You have to mention whether it is C1 or C2, because again the examiner will get confused where you are actually taking. So this is C, this is F, O, F, C. Okay, C1. Okay, the object is beyond here, beyond C1. So when it is striking the lens, it is traveling parallel to the principal axis. So when it is traveling parallel to the principal axis, after striking the lens, it travels through F2. Then after that, you can take the third case, right, wherein it is actually so if you see, image is actually formed between F2 and C2. So therefore, if you see the size of the image, this is actually more greater, a little bit more greater. This is a little bit bigger image, bigger object as compared to the image. Image is very much small, so it is kind of diminished. Therefore, it is real, inverted, and diminished. That you have to remember. Right? I got an understanding, right? So it is inverted. So where the image is formed between the F2 and C2, you have to mention. Otherwise, if in the exam it is asked, you try to mention here as A, B, then A1 and B1. So if you mention like this, and finally you tell the A1 and B1 is the image. Okay, like this you can do. Okay. So then the third case, if you go to the third case we are actually putting the object at C. So where we will get the image? You know, right? Where we will get the image? We'll get the image at again C only. Okay. Object at C, right? Somewhat here exactly at C2 you'll get it. So for only this case, if it is asked in the exam, try to do it perfectly, because when you actually do it in a graph paper, you'll get it perfectly and exactly. But when you're actually doing it on the answer sheet, you'll not get it perfectly. You'll get somewhere here or beyond C, like that. Those cases are actually mostly seen when you actually draw, because we'll not have any perfect graph perfect graph you not draw. So in that case, try to draw it perfectly. Use your methodology, your own ways, in order to arrive at a particular and a correct result and correct solution. Okay, so it is where the object is at C1, so image is formed at C2 only. So what is the nature? So it is real, it is inverted, and it is of the same size. Okay, then let us move to the fourth case, when the object is, so did I draw perfectly? Let me check once. Right. Oh, just I got it. Okay. When the object is, no, first we have taken infinity, next beyond C, next at C, then we are going to say between C and F. So it is traveling parallel to the principal axis. After striking the lens, it travels to the focus. Okay, so this is point O. Then where we'll get the image? We'll get the image beyond C. So we'll get the image beyond C. What is the size of the image? It is slightly bigger as compared to that of the object. Therefore, it is magnified, or you can say it is enlarged, magnified. It is again, this means real, and means inverted again. So this is the point. These are the important points that you have to remember with respect to this, right? Now you got an understanding, right, how we actually progress, how we actually get an idea. So object, where the object is between F1 and C1. Okay. Next, the fifth case. So the fifth case is a kind of case where the object is located at infinity. Okay, then where the image will be formed, where the image will be formed. So object is located at F and the image is formed at infinity. So if you see these both lines are both parallel to each other, that means they'll never meet at a point. Therefore, the image is actually formed at infinity. Then you can say it is real, then it is an inverted image will be formed, and it is highly magnified or highly enlarged. Okay, this is the points. Then next, sixth case, the object is located. This is a very important case. If mostly a question is actually coming from the ray diagrams, then this will only come. Okay. What is this? If you see this one, the object is located between the optic center and the focal length f1. Okay, so where the image will be formed, if you see. So this is the only condition where the image is actually virtual. In all the conditions, I actually saw that image is real and inverted. But this is the only condition wherein the image is going to be virtual. You can take anywhere. It is not particular that the image should come only C1, C1, F1. It is not that. Just you can say that image is actually formed behind the lens, or image is actually formed on the same side of the lens. Okay, on the same side of the object. So that is the case. So here in this case it is highly magnified, then it is real, then it is virtual because it is formed this side. So all the images which are formed this side are real. So if it is formed this side means it is virtual. Like this you have to remember. And virtual, and it is erect. Okay. So these are the 6 cases with respect to the concave, convex lenses. Okay, now you got an understanding, right, how it will actually go on, right? If you see, it is not particular that you can get F, you can get anywhere, whether it is a case wherein you get beyond. So if you see here also, it is not mentioned. So this is the 6th case. On the same side of the lens, you'll get the as the object, where the object is placed, in that side only you'll get the object and you'll get the image. So this is the case which you have to remember, right? Now you got an understanding, right, how we'll actually remember the points. Now let us move to the concave lenses. After this we'll move to the magnification, the numericals, everything is solved, right? So then concave lenses. So if you see the concave lenses, what we're actually going to see with respect to the concave lenses is that concave lens is considered to be a diverging lens. You have to remember this point when you are actually drawing. Only 2 cases are actually there. Okay. So object is located at infinity. When the object is located at infinity, it is divergent. The image, then you have to extend this back. So then this one, the object is where the image is formed at F1. So this is the case where the image is formed at F1, right? But then understanding, right, how it will actually go on. Right, now let us try to understand the second case. When the object is at infinity, image is formed at F1. Okay, that means it is actually appearing to meet at F1. So in the second case, you see the object is at any point you can take. It is not particular that you have to take it only this point or that point. You can take it any point. So anywhere you take the object here, or you can take it C1 or anywhere. With anywhere if you keep also, you'll get a constant image formation for these concave mirrors. Is formed between F1 and O. Okay, if it is formed between F1 and F, you take here also, the light is actually travel this side only. Okay, then after that also it is moving here also. So they'll meet at F1 and O. Anywhere you take the object, the image is formed between F1, that is focal length 1, and the optic center only. Okay. So these are the 2 cases. Oh, then what is our image formation for? The image formation, then it is going to be a virtual image because it is formed that side. Virtual it is going to be, then it is going to be erect. It is also going to be diminished. A question can come. Which lens will form both a virtual and real images? It is a convex lenses because it forms in all the cases you can see the real images, but in the 6th case you can see that image is actually the virtual image is actually formed. Okay, so these are the 8 important real diagrams that you have to remember. Sign convention with respect to this, as I already told you, depending on that you have to take. For example, for the convex lenses, if you see that image is actually focused at F, right? So this focal length you are going to see. That means it is in the direction. That means for measuring the focal length, what you are actually doing, share the whiteboard. So what you are actually doing, you are actually trying to focus, you're actually trying to measure it from the optic center to the focal length. That means in the direction of the light rays only. Therefore, that is considered to be positive. If focal length for the convex will always be positive. Okay. Then for the concave lenses, what is going to be? So then focal length will be constant, and you have to remember that this is a kind of a thing you have to always remember. U is always negative in all the cases. Concave, concave mirror, convex mirror, concave lens, and convex lens. So all the cases u is always going to be negative, and the v will actually change depending upon the question. So if you see in all the cases of the convex lenses, you see that the image v is actually going to be positive only, because it is actually measured from this side. The image is actually measured from this side, right? So it is mainly going to be positive one. But in the sixth case, if you see, image is actually formed somewhere here. Therefore, you are actually going to measure it from here to here. That means against the light rays. Therefore, this is the only case you see that v, that is image, is going to be negative. Otherwise, you get to know that, you get to see that all the cases, the image is mainly going to be positive only. Okay. Then if you see for the concave, it is easy to remember because it will always form a virtual, and is always virtual only because only two cases are also there. So if you see for the concave, image is actually diverging and it is appearing to form at focus, right? So in this case also, what is actually happening is that the focal length will always be taken as negative. Okay, why focal length is always negative? This is actually because it is measured from, so these, see, if you see the light rays are actually moving from this side, but we are actually trying to measure it from this side, right? So this is against the light rays, focal length is negative. Okay, then u is always negative. This you can easily remember, and v is always negative. V is also negative because v image is actually formed here only. So that means against we are measuring. So these all are the important cases. So for concave lenses, you can easily remember it. Okay, for convex it will vary. Okay, for convex also you can remember because so let me actually give a chart about an entire convex and concave things also. So concave and convex. So these are the mirrors first. Mirrors would go. Mirrors, lenses. Concave, convex. You see the side headings and go with that only. Okay. So if you see u always negative for all. So these are the very, very important signs. Definitely a question of numerical question will actually come. Okay. So focal length. For concave mirror, it is always negative. For convex mirror, it is always positive. Okay. For lens also, concave lens also, it is always a negative. Right. For convex lens, f is always positive. So what you actually get, so these points will be common for all the things. Right. So concave mirror and concave lens, the points are going to be same. For the convex lens and convex mirror, it is going to be both the same. Okay, u will always be negative. The focal length is the only one which is actually changing in all the cases. So this is a very, very important thing that you have to remember. Okay, with this only you are able to solve all the important questions as well. So let us actually go. Now you got an understanding, right? Now let us actually try to understand the numericals. Let's go with the numericals. After that you can see. So and lens formula also. That lens formula is nothing but it is just the case wherein, okay, lens formula if you see, so mirror formula 1 by f equal to 1 by v right. The for a concave for a mirror formula 1 by f equal to 1 by v plus 1 by u. For lens formula 1 by f equal to 1 by v minus 1 by u. You can't write it as 1 by u minus 1 by v. It is absolutely a blunder mistake that you have to not do when you're actually trying to solve this kind of questions, right? Now this is the lens formula 1 by f equal to 1 by v minus 1 by u. This is the mirror formula that you have to remember, right? Now let us try to understand this. The first numerical, this numerical they are actually giving about, it is about a concave lenses. So concave lenses, then focal length will always be negative. U will also be negative. At what distance to the object from the lens to be placed so that it forms an image. Here actually that what is actually given, focal length is given image is actually given and they're actually asking object distance. They're asking you. So generally they do not ask you, but if they are asking you, you must be very particular about the image. So it is always minus u, then v. So you don't take it as minus or plus now only, because for the unknown values, don't take it as minus or plus. Just you take it as u only. Okay. So then v, I'll try to write. Okay. So what is actually given, you write v equal to minus 10, f equal to minus 15 centimeters. And we have to find u, right? So 1 by f equal to 1 by v minus 1 by u. And after the 1 by f is minus 1 by 10, because I'm just taking the minus sign to the numerator. Okay. And minus of 1 by u. So then after that 1 by f is minus of 1 by 15. Okay. Then after, what we are going to do after that, we are going to take this minus 1 by 10 towards the left side. Okay. To take all the values towards the left side. So what you'll get, so minus 1 by 15. So minus will become plus. So 1 by 10 you'll get. But this minus 1 by u will remain the same. Okay. This will remain the same in the question only. So try to solve the question quickly. So if you take the LCM is going to be 30, right? So if you take if you do, the LCM is going to be 30. So this is into 2 you multiply into 3 and into 3. So minus 2 plus 3 by 30 equal to 1 minus 1 by u. So 1 by 30 equal to minus 1 by u. So u is equal to minus 30. Yes, we got check. You remember that you should get always a u value negative only. If you are getting the u value as positive, you might have done a mistake. That you have to remember. You should get always negative only. Okay. Then they're also asking the magnification produced by the lens. So magnification m. So if you see for the lenses or mirrors, magnification is minus v by u. But for the lenses, it is just v by u. What is the v value we got? V value we got, it is given that minus 10, right? Then what is the u value? U value it is minus 30. So 0, 0 cancel. Then you are going to get something like 0.333, something like that. So if it is, so if you see here, it is less than. So if it is getting positive and it is less than 1, less than 1 in the case type, that means if the image is which is actually formed is diminished image. That means object is more greater as compared, the height of the object is greater than that of the height of the object. So can you actually find the height of the image and height of the object? No, we cannot find, because at least one value of the height of the object or height of the image must be given in order to find the height of the object or the image. So at least, so they must give at least hi in order to find ho, that is object. They must at least give height of the object in order to find height of the image. So then when both these cases not given, then you cannot find the height. Okay. So this is a very important thing. So the positive sign indicating that it is a virtue. So before we saw that positive sign is also negative sign, it is indicating that it is real, right? In that case, but positive sign is indicating virtue. That is also same for this situation also. Now let us try to see the next question. The next question we are actually focusing is about okay. So here they get 2 centimeters tall object. So that means height of the object is 2 centimeters. Next. Convex lens, lens you have to remember. Focal length is always taken as positive. Okay. And the distance of the object from the lens is 15 centimeters. Distance of the object. So u is always negative. So minus 15 centimeters. So what you have to find, v we have to find. Okay. So again 1 by v. So indirectly 1 by f equal 1 by v minus 1 by u. So it is 1 by 10. So plus 1 by 10. Okay. So then v value we have to find. So 1 minus of minus 1 by 50, right? We have to find the v value. 1 by 10. If you see here, plus minus will become plus. Okay, so this minus. So if you see here, so it is always said that minus and minus will always become plus, right? So this also minus will become 1 by v equal to plus 1 by 15. So when you take this minus 15, 1 by 15 this side becomes 1 by 10 minus 1 by 15 is equal to 1 by v. Are you understanding? So here minus and minus 1 by 15 is there. So actually, so minus should always be in the denominator, but actually shifted it to the numerator based on your convenience. Okay. So then it becomes minus and minus. Therefore, this minus will become plus, right? So what is the LCM here? Again, the LCM is going to be 30 only. Okay. So then we are going to multiply. So 3, here 2, 2. So 3 minus 2 by 15. 30. So 1 by 30. So V value you are getting it as positive. So you should get, mostly you'll get all the cases V value positive only. Otherwise in the last case, you'll get the V value as negative. Then you are actually asking the magnification. Magnification is V by U equal to Hi by H naught. H R. Okay. V value are actually getting 30. Then height of the object is minus 15. Then height of the image you have to find. And height of the object is actually given in the question as 2 centimeters, right? 2 only, right? 2. Now we'll find. So then this 15 and this 2 will cancel, right? 30 will cancel, so we'll get here minus 2. So minus 2 into 2 equal to cross multiplication, HI. So HI is equal to 4 centimeters. Let me check actually if it is 4 centimeters. See, if you see here, height of the image is minus 4 centimeters. Minus 4 centimeters. Okay. Then the magnification is minus 2. So in this case also, so magnification magnification minus plus V by plus so that is 30 by minus 15. So it is cancelled, so minus 2. So that way we actually found everything, right? So this way also we have found the last case, right? Now let us try to see the last important topic, that is the power of the lens. So we need 4 minutes. Oh, perfectly, we can complete in 4 minutes this power of lens. Power of lens is nothing but it is actually telling about the focal length. Okay, power of lens will actually tell us about the convergence of the divergence of the lens. How much converging the lens should be, or how much diverging. If you go to a doctor also, they'll actually give you're actually having minus 3 diopter, they'll say. So what is actually this minus 3? They'll say your sight is minus 3, your sight is minus 1.5. So depending on that, they'll try to say, right, whether it is minus 1 or minus 2, minus 3, right? So then what is actually this minus 1, minus 2, minus 3? So that is an important thing that you have to remember. So therefore, a concave lens of a very short focal length causes a high divergence than the one with a longer focal length. Okay. Then the degree of the, what is actually power of lens? Power of lens is nothing but it is the reciprocal of the focal length. So reciprocal of the focal length is considered to the power of lens. Which will actually tell us about the convergence or divergence of the light rays. That means for you, see, for every person the light. The specs are not going to be the same, right? So if you go to the doctor, they'll tell that it is minus 3 diopter, in the sense that minus 3 it is actually converging lens, minus 3 diverging, because minus 3 so it will always, so you have to remember, if it is minus 3, so the power is actually given as minus 3 diopter, then it is concave lens. You have to remember minus will always represent concave. Then the power of lens is actually in plus 3D, then you have to remember that it is convex lens. If you go to the doctor, if he says that minus 3, that means minus 3 diopter they are actually given, that means your focal length, your actually eyelids must be converged to that, up to that extent. For example, let us actually solve the questions as well. Okay, so a convex lens of a short focal length will bend the light rays through the large angles by focusing them to the closer optic center. So if you see, the SI unit of this power of lens is called as a diopter. For example, let me actually solve the questions now. Okay, and focal length is always expressed in meters. Sometimes what they actually give, so focal length they'll try to give it as 40 centimeters. Either do one thing, either try to convert this 40 centimeters to meters. That is 40 by 100 you get it as 0.4. Or else keep it in 40 fraction only. Otherwise what you do, then after that what you do, P equal 1 by F, no? Then 1 by 0.4. 1 by 0.4 is nothing but 10 by 4. That means 2.5. That means it is 2.5. 2.5 D. So this is the value you got. Here it is positive. Positive in the sense it is convex lenses. Okay. Then in the same way, if it is actually either do with, always convert centimeters to meters and then solve the question. Okay. So and then after that, in case sometimes they'll give power. Power they'll give it as power they'll give, and they'll ask you to find the focal length. For example, like this they'll ask. Minus 50 centimeters they'll ask. Okay. Let us take negative value. Power equal to minus 50 D. So then it is 1 by 50 you take. So P equal to 1 by F, right? So F is equal to 1 by P. So P value. So this question I substituted. So minus 1 by 50. So then you take the division. You'll get something 0.02, right? So 0.02 you'll get the value. Okay? 0.02. 0.02. So 0.02 meters you'll get. So this is the value which you're actually getting. Okay, so what you're actually doing here, we're actually doing with 1 by 50. So by doing that, you're actually getting the value in meters. Okay, if you want, you can actually convert it to centimeters. If you convert to centimeters, what it will be? 20 centimeters, you'll get it. Okay, so in this way, you can actually solve the different type of questions, right? So it is always expressed in meters. So what if in the question, what if it is asked the SI unit of power of lens is diopter? Diopter is represented with D letter, right? It is already 45 minutes. It is okay. Diopter it is represented, right? So then 1 meter. So 1 meter is always nothing but, so if you see here, so 1 diopter is the length of the power of the lens whose focal length is 1 meter. That means 1 diopter is nothing but you're always taking focal length as meters. Therefore, it is nothing but power of lens whose focal length is 1 meter is considered to be 1 diopter. Okay. That means 1d is equal to 1 by 1 meter. 1 by 1 meter you can choose. Okay. Whose focal length is 1 meter. Because 1 diopter only we are actually seeing. So that means 1 meter. So 1 by 1 meter. Okay. So therefore, 1 diopter is nothing but the power of lens whose focal length is 1 meter, because focal length is the SI unit. So so here in this case we are mainly going to see the focal length they are actually taking it as meters. Therefore, depending on that, you have to actually solve different kind of questions. Okay. Now, if you see here, so it is plus 5.0. Okay. So then what you're actually getting, this means it is a convex, then focal length is actually going to be 0.50 meters. Okay, so then similarly the power of lens is minus 2.5. so just remember it is concave, that is diverging, then if it is plus, that is convex, that is converging lens. Okay, then define 1 diopter. 1 diopter of the lens is nothing but it is the power of lens whose focal length is 1 meter. That's it. A convex lens forms a real and inverted image at a distance of 50 centimeters from it. Real and inverted image at a distance of 50 centimeters from it. So where the needle has to be placed in front of the convex lens if the image is equal to that of the size of the object. Image is equal to that of the size of the object means where it is actually placed. That means, so if they are actually convex lens forms a real and inverted image, so they are actually giving the image distance here. Okay, so that is 50 centimeters, right? It is plus 50 centimeters. Okay, then the image, so they are actually telling that the height of the image is equal to the height of the object. Then in which case we'll get when the object is placed at C, center of curvature, we will actually get C1. Then we'll get the object when object is at C, C1. You see here this case, so when the object is at C1, we are getting the image at C2. That means this is the only case we actually get. The object is, then what is the question they are actually asking? They are telling that then where the needle must be placed in front of the convex lens, it must be placed at C1. Okay, and also find the power of the lens. What will the power? So 50 they are actually telling. Then focal length what will be there? Half, no? So that distance is a radius of curvature, right? So f is equal to r by 2, right? So then r is equal to 2f. So they're actually asking focal length. Focal length is nothing but r by 2. R by 2 is nothing but 50 by 2. 50 by 2 is 25. It is minus 25 because focal length are also, no, it is plus size also. Plus because I'm actually going to take for convex lens focal length as positive only. Okay. So then power is actually going to be 1 by 25 you have to take. Right. P equal to 1 by f. That is 1 by 25 you have to take. Then if you solve like that, what will actually get the value? 0.04. 25, 1. 0.04 you'll get. So therefore 0.04 D is the power of that particular lens. Then what is the power of concave lens of focal length? 2 centimeter. Concave lens means what we have to take? Focal length is always negative, that is minus 2. So power P is equal to 1 by F, that is 1 by minus 2. Then you are going to get 0.5. Right? It's already given in meters, so directly you can substitute. No need to convert to anything else. 1 by 2, it is nothing but minus 0.5 D. Okay, so this is a convex lens. Power lens is concave. So concave you have to take it as it is always negative, and convex it is always positive. So this is the important thing that you have to remember, right? So with this we complete this refraction part, and in this 15-minute class we have actually completed this entire thing. 54 minutes it got, right? So finally we actually completed this refraction, and with that the entire light chapter is completed, we have actually divided the video into 3 different parts, right? So with that, everything is done, and I'll try to see if we can actually, if I can actually bring out few different type of questions as well, and different type of question. And CBSE also recently released sample papers also, right? So just you go through those sample papers also. Any doubts are there, just you try to comment them down in the comment section, so I'll try to answer them also. Okay, then you also comment on whether you are able to understand our concepts or not as well. So based on that, I feel happy whether actually understanding. If any changes you want actually from me, any improvements you actually want from me, also try to comment them down and try to check it out. Okay, so with that, we are actually trying to end the session. So see you all next time. In the next session, I'm actually coming up with different type of questions. So with that, social is done. Social is done. With this, science is also done. Physics, chemistry, biology also one lesson I have completed. And let me see. Okay, let me actually think. Okay, with this, let's end the session. So try to practice all the different kind of questions. As more you try to practice the questions, more you'll be perfect with the concepts also. Okay, so that you just do it. So with that, I'm actually ending the session, and I also request you all to please be safe. Enjoy this year, because this is the most precious and most important year for you also. Okay, so with that, I'm ending the session. Stay safe and be happy also. Okay, bye everyone.